When I look at number 9 here, I'm seeing a product, the logarithm base 6 of a product, right? You got a multiplication going on there. So I'm going to use that first property where I break a product into a sum of the individuals. So it's going to be, how about the log base 6 of x squared plus the log base 6 of y to the fourth. And now I see I've got bases to exponents here, and I know by the third property of logs I can bring those exponents down in front as multipliers. So I'm going to write this as 2 log base 6 of x plus 4 log base 6 of y. Now, do you think you could go from here to here directly? When you see powers, what do you know is going to happen? You know they're going to come down in front as multipliers. And if you see a multiplication, you know you're going to end up with an addition. So I'll write one, see if you can do it. Take the log base b of, say, a to the fifth, b to the ninth, c to the fourth. Maybe pause the video for a minute and just see if you can do it. All right, so I'm going to go direct. I see a product here. So I know these are going to be additions here. Log of this plus a log of this plus a log of this. These exponents are going to come down as multipliers. So how about this? 5 log base b of a plus 9 log base b of b, interesting, plus log base b of, not quite. What is this one going to be? Got to bring that 4 down, right? I forgot the 4. Bring that 4 down as a multiplier. 4 log base b of c. Now, look, we can actually go further. What do you know about this? Log base b of b. It's an exponent. What exponent do you put on b to get to b? It's just a 1. Remember, we talked about this one in the last section, I think. It was log, see if I can write it here, log base b of b, that's just equal to 1. So that's just a 1 here. So when I rewrite that now, this is going to be 5 log base b of a plus 9 times 1 plus 4 log base b of c. 9 times 1 is just 9. So how about if we just write it as 5 log base b of a plus 9 plus 4 log base b of c. So sometimes you can take these a little farther than you maybe originally thought. Look at this 13. What are you saying here? Do you see a product, a quotient, or something to a power? Well, when I look at that globally, I'm seeing a quotient. Now, the quotient rule says take the log of the top minus the log of the bottom. So I'm going to write this now as the log base b of the top, which is xy, minus the log base b of the bottom, which is z. But then what do you see right here? You got the log of a product, so I can stretch that out into a multiplication and write it like this. The log base b of x plus the log base b of y minus the log base b of z. Now this happens every time. See, I've got a quotient. Look at the numerator. I got xy in the numerator, and look at these logs. They're both positive. And the denominator, that's negative. So when I look at a quotient, I'm going to break it up like all at once. I'm going to go from here to here. And the tops are going to be positives, and the bottom's going to be negatives. Now we'll see that again in number 15. I'll stretch it all out, and then we'll see that you could go from the beginning right to the end immediately. But what I'm seeing here, first of all, is a quotient. So this is going to be the log of the top, which is the log base 10 of 4, which I don't know, but minus the log of the bottom, log base 10 of xy. But now this xy, this is the log of a product. This is the log of a product. I'm going to stretch it out into the sum of 2 logs. But I got a minus sign here, so I'm going to have to use parentheses to capture the whole sum. So I'd write it like this. Log base 10 of 4 minus, parentheses, all of this. Now this thing here breaks into this. Log base 10 of x plus log base 10 of y, and then send that minus sign through. So it becomes log base 10 of 4 minus log base 10 of x minus log base 10 of y. And then if you look at it as a whole, right from the beginning to the end, all right, it always works like this. It's going to be the positive, whatever's on the top is the positive log. Whatever appears on the bottom, you get negative logs. Right, so right away I can see, okay, log of 4, positive. And then I get, oh, I got the bottom, minus log x minus log y. This number 23 looks on the outside a little bit intimidating, but I think we can fix it up pretty quickly. First of all, when you look at those three properties of logs, you don't see anything with a radical in them. So let's get rid of the radical and write that in fractional exponent notation like this. This is the log base 3 of this quantity, x squared y, over z to the 6th, all to the 1/3. And now what I see is this is the third property here. I've got the log of something to a power. So I know what to do. I just bring that power right down in front. So this becomes 1/3 the log of x squared y over z to the 6th. And then, from what we said in the last two problems, 13 and 15, we've got the log of a quotient. Now, the tops are going to become positive, pluses, and the bottom is going to become a minus. So I'm going to write this now as 1/3. Now, I'm going to stretch it out, so I need a parentheses or a bracket in this case. I'm going to say the log of base 3, the log base 3 of the top, x squared, now plus, because I got another top, log base 3 of y, and now comes the bottom, so this is a minus, the log base 3 of z to the 6th. And now, what happens to these powers? I got a power here and a power here. Those come down as multipliers. So what are we going to have here? It's going to be 1/3 times, now bring those powers down as multipliers. So how about 2 log base 3 of x plus, no power here, just log base 3 of y minus, now bring that exponent down, 6 log base 3 of z. Now I suppose we could leave it like that, or if we wanted to, we could bring that 3 inside. And if I brought that 3 inside, it would be 1/3 times 2, so that would be 2/3 log base 3 of x plus 2/3, no, that's not right, come on now, come on, 1/3, right, I'm multiplying here, 1/3 log base 3 of y minus, oh, what do we have? 1/3 of 6, 6/3, which is 2. So how about just 2 log base 3 of z?